Okay. So in Arctic, which is in the northern pole, is the ocean. It's a oceanic region with thin ice layer, while the Antarctic is in southern pole, which is colder than northern pole, and it's like with covered with, it's a continent and covered with very thick ice layer. So the temperature at Antarctic is relatively very low, or you can say compared to Arctic, it's very low. And because of the low temperature, which can go up to minus 89 degrees centigrade, while the in Arctic region, the temperature minimum temperature would be around 50 minus 50 or something. So because the Antarctic region, which is in southern pole, is very cold, there is a possibility of uh, polar stratospheric cloud formation, which contains HNO3. The color of this cloud is very different. You can see the image from NASA on the left hand side. The color of this cloud is pinkish or orange, while it's not like normal cloud, because it contains HNO3, and HNO3 reacts with um, chlorine, which is like, so on the right hand side you can see there are two reactions are shown without polar stratospheric cloud and with polar stratospheric cloud. So when the polar stratospheric cloud is not there, then any chlorine compound, CFC or other compound, they react with ozone and form ClO and NO2, and then ClO NO2, right? Which is chlorine nitrate, which is known as chlorine nitrate. And HCl will also form. Then if the cloud is present, then what will happen? This ClO, NO2 and HCl, because HNO3 is also present in this cloud, and they and because of the sunlight, this will means this HNO3 will react with ClO, NO2, and it will again produce Cl2. Okay. Cl2, then again it can dissociate as ClCl because of the sunlight, or because of the, you can say, photochemical reaction, and then it can react with ozone and form ClO. So this is like a kind of chain reaction which will go on until the Cl as a nascent Cl, or you can say radical, Cl radical is available in that place. So that is why we see, uh, I'm sorry, what happened? Okay, that is why there is a large, or you can say largest hole in Antarctic, the compared to Arctic region. Or so it's a because of this cloud formation, and at low temperature, the ozone layer is getting widened in Antarctic region. Now, as I said, because the Montreal Protocol set to uh, stop or ban the production of CFCs and other bromide compound and other compounds, and we expect the improvement in ozone layer, right? And it was seen, you can see on the right corner, ozone hole by area is given. So when you go from 2006 to 2008, even 2015, you can see there is a decrease in ozone area in million kilometer square. But in 2020, 23.5, while in 2001 it was 25 million kilometer square. But just recently I was searching some text in this regard. I found that in 1919, is that given here? No, right? 2019, not 1990. 2090, there was a eruption of volcano, and that again caused the widening of ozone layer. However, whatever that is a like certain event which happened in that particular year, it's not a regular event. The scientists estimate that this ozone layer will become as it was in the beginning um, in 2070 or something. So it's like still we have 50 years to get this ozone layer closed. If there is, because this chlorofluorocarbon and other compound has very long life in the atmosphere. They do not degrade very quickly and disappear. As that is why they have the chain kind of reactions, right? So it will take another 50 years probably to get the air as it was before in 1990s. Okay, so here I have also given a link to one of the video from NASA. You can watch this video if you want to know more about the ozone layer. So I have already explained why does the PSC form in Antarctic southern pole, not in northern pole. So this is the kind of reaction that happens. We have already discussed this last time. So yeah, so this is Montreal Protocol. I told you that reduction in CFC and use of HCFC was started under this protocol, and there is an improvement. But here, see, here it's written full recovery will not occur until 2050, means 30 years. In some places it is saying 2070. So I don't know, means exactly nobody can say. They are just what nowadays, because of the satellite data is available, they are watching this ozone layer every time. You can say daily, even hourly average data is available, and there are many research paper on hourly or daily average ozone depletion and all those things. I'm not going to discuss it. If you are interested, I will upload one of the recent paper. If you want, you can go through it. Okay, now the second type of secondary pollution is photochemical smoke. Photochemical smoke forms because of the reaction of volatile organic carbon and NOx. Okay, basically NOx and VOC are the major player in photochemical smoke formation. Primary pollutants, the two major primary pollutants, nitrogen oxide, as I said, and VOC are there, and they combine and they form the like various chemical compound. And one of the most you can say common compound is PAN. PAN is peroxyacetyl nitrate. Peroxyacetyl nitrate. This compound was first um, actually seen over Los Angeles in 1950s. So it's a brownish haze which can be seen if there is a photochemical reaction between oxygenated volatile organic carbon VOC, but that are oxygenated VOC. That means the VOC whatever is emitted from any combustion sources is it gets extra oxygen during oxygenation reaction, and these oxygenated VOCs are very reactive and they react with NOx and NO2 or NO whatever, and they form and also there is a presence of various organic compounds such as acid, acetaldehyde, acetone, methyl ketone, etc. And these compounds, when they react, these are actually VOCs, oxygenated VOCs. When they react with NOx and all, they form PAN. Now, this is the simple reaction which is given by US EPA, how this PAN formation takes place. NO2 plus sunlight, NO and O form, then O plus O2, O3 ozone form, then O3 plus NO, again NO2 plus O2 will form, right? Then NO2 plus R will give the product such as PAN. Okay. So this is the simple way of presentation. However, these compounds which I just mentioned is acetone, methyl ketone, methyl glyoxyl. There are several compounds. They are very complicated compound. If you find out their formula, it's fine. Otherwise, in just to see how they look like, but it's not necessary for you to find the formulas. Okay, now if this secondary formation of ozone and pan is very important, then we need to know what are the sources that emit VOC and NOx in India, especially. See, I don't know if you have seen any time this brown haze in Delhi or any other place in cities. Probably not, because maybe that kind of reaction means in our places it's a tropical region, so dilution and dispersion is very you can say frequent, especially during summer when temperature is high or in monsoon when temperature is high. However, there are regions where this happens, and one of the region where you can see the brown smoke or smog is over Indian Ocean. So there was one, you say, campaign in 1990s, which is known as in Indian Ocean Experiment, Indo-X. That that campaign was led by multiple institute, international institute, academic institute, and research institute, and it was planned because we observed the brown haze over Indian Ocean, and everybody wanted to know how this haze come over Indian Ocean and what are the sources of the this formation, secondary formation, and uh, where these sources are located. So it was a big campaign in 1990. So in general, you will not find photochemical smoke formation over various region in India, but there is a formation over Indian Ocean some time back. Right now, like current situation, I don't know. So the sources which are responsible for VOC emissions are biogenic sources as well as anthropogenic sources. Among anthropogenic sources, vehicle is one of the major source of NOx and VOC emission. Combustion of various other fossil fuel like coal in power plant, wood burning, etc. are also responsible. Here on the right hand side, this is our paper which was published in 2018. The NOx emission from on-road transport is shown. So the red you can say lines or these are the actually highways where in general you can say heavy duty vehicles move on national highway and state highway. So these are the national and state highway where heavy duty vehicles powered by diesel moves in this on these roads, and the green inside these boxes are actually urban area where basically we have um, petrol driven cars, etc. So this is how this is like and you can see the total NOx emission, annual NOx emission is 4052 gigagram per year, which is very high, right? So this is the reason we also have heavy secondary pollution in urban areas, but we don't see the brown haze or pan formation in India. Okay, maybe in some places, but I don't know or I don't have any record of those places. But in general, I did not see it in Delhi. But we do see smog events in Delhi, right? Can you tell me when is probably we see the smog event in Delhi? Anybody? You
Winter,
Ma'am,
yes,
during November,
winter, December.
winter
yeah.
time.
Just before winter, during post monsoon, you see this event, smog formation event, after burning of biomass in Punjab and Haryana. Okay, and so this whole event, as well as plastic burning in Delhi, or maybe nearby region, waste to energy plants in various other region, as well as in like not in India, but in European area and all, that actually gives the chloride compound, and as I told you last time, HCl, plastic burning gives HCl, then NH4Cl can form. So this all secondary formation of ammonium chloride or other chloride related compound, even ammonium sulfate, ammonium nitrate, secondary organic compounds, this actually uh, together called as smog. Okay, so this okay, now if we know that there is a problem, this problem is because of anthropogenic sources, we should also know like what is the energy trend in our country, what like how it is increasing, and what are the different other sector other than on road vehicle which are responsible for such precursor emission in India, and therefore the formation of secondary particles. So here you know this is on left hand side. This is the petajoule energy use or consumption in India in different sectors, and among that you can clearly see on road diesel is one of the most or largest consumer of energy, you can see. And then HESH, which is large point sources, which is power plant, etc. Okay, on road gasoline and CNG are very low compared to diesel.
Ma'am, where is the data?
What?
Ma'am, we can't see the data you are speaking about.
Okay, you don't see this figure on the left hand side?
Yeah, now we are seeing it.
Oh, okay, maybe like it's animated, so but I can see it even. Okay, so you can see the top figure where petajoule of energy consumption is increasing with time, with year. Can you see that?
Yes, ma'am.
Yeah.
Yes, yes.
So here you can see the gray, dark gray is thermal power, coal and gas and oil. Above that is a large point source, coal and gas. That is not thermal but other industries which are large point sources, like say in steel industry, cement industry, and so on. ठीक है? The white are other industry means they are not large point sources, but they are medium size industry and so on. Then you can see the on-road diesel, light gray color, and on-road gasoline plus CNG, uh, the box, or you can say checks on the top. So actually what the purpose of this figure is, see the largest consumption of coal, because we still have the thermal power plants. We don't have nuclear power plants and so on in many places. It's like old technology is working, is still working, and this thermal power plant energy consumption is very high. But if you see the on-road diesel, which is low, means compared to these sources, this is insignificant, you can say, but it is growing fastly. The growth in on-road transport sector is very steep. You know, see, it's getting larger in 2050, and now it would be more because with the growth with the growth in population and economy, more and more like four-wheeler, two-wheelers are being used in Indian cities. So this is the very steep growth sector. This sector has very steep growth, you can say. So this is how. Now, here some facts are written. 830 large PowerPoint sources we have: iron, steel, fertilizer, cement industry, etc. More than 1 lakh brick kilns are there in India which are working. We do not have complete data set to actually estimate the emission from these brick kilns, and in our group we are doing that. Greater than 50% of population still uses solid biomass fuel. Okay, 142 solid biomass fuel means wood, dung cake, crop waste, etc. 148 to 350 teragram biomass burned in open field. Okay, so these are the major sources in India responsible for emission of not only the primary pollutants but also the precursors of secondary pollutant. That bottom figure on the left side is giving us an idea of emissions of various um, you can say black carbon, organic carbon. Just don't remember that, because this is something you don't need it. But PM 2.5 you can see SO2, NOx, non-methane volatile organic carbon. All these are given here, and you can see the largest emitter is residential biomass, which is fuel wood, dung cake, and crop waste combustion in rural area in India is the largest um, emitter of non-methane volatile organic carbon and PM 2.5. Okay, industrial coal power plant, they are also the significant you can say emitter of sulfur dioxide and nitrogen oxide, which are the precursor of secondary particle formation. So this is a kind of overview about the emission from various sector, and so that is what I wanted to show. Then what is the evidence of secondary particle formation or smoke formation in Delhi? So this is another paper we published in 2020 in atmospheric chemistry and physics. This is simple diagram where you can see on the left hand side particle number. Okay, number of particle in the atmosphere of different size range. So NACC is accumulation size range, NAIT is Atkins size range, and NUC is actually nucleation mode. So what is actually you can remember it like this. Nucleation mode means particles less than 30 nanometer in size. Okay, and these particles come only from fresh combustion of any kind of fuel. Okay, if the combustion is fresh, these particles get into the atmosphere. They may have the organic compounds which can further react with other species and form some secondary pollutant, but these are very freshly emitted particles. Accumulation mode particles are those which are after some time, when these small particles condense, or you can say coagulate with each other, or goes through various reaction and form bigger size of particle. That is accumulation mode particle, that is actually greater than 300 nanometer or 500 nanometer in size. In between these two is Atkin mode particle. So greater than 30 nanometer and less than 500 nanometer you can say is Atkin mode. It's not necessary for you to remember this very means this is not a part. Just I want to convey a message that if you will see, and the purple color, which is on the top, and the orange color. Just focus on these two. You can see that this particle range, which is the small, very small range, less than 500 nanometer in size, are major contributor of total particle number in Delhi. What does this mean? This means that the the fresh emission is high in Delhi, because this is the city where you will find like cars and various other sources, and the pollution also comes from other area, other region, and at the same time the particle is going through various processes, and they are becoming bigger in size. Okay, so secondary pathway of particle conversion, or the gases conversion, or can say the growth of the particle is available. Okay, so that also indicates a kind of maybe secondary formation of particle from VOCs emitted from various sources is taking place. Here, I do not want to explain each of them, but just focus on right hand side bottom graph. Okay, can you see the monsoon, the particle mass concentration is low, PM 2.5 and whatever PM, I think, zero point 0.5 is low, but you can see the green color is significant compared to winter. Can you see the green color? Green color area is significant compared to winter. Why is this so? Monsoon is a clear period. How come there is a large amount of, or large mass of nucleation mode particle? What do you think about that? Why is this so? Monsoon should be very clear, right? It's a rainy season. Can you comment, because I have taught you something in last class also regarding secondary formation and all. Can you comment why is this so? Anybody? What is the difference between winter and monsoon?
Ma'am, humidity. Humidity is
Yes, high humidity. Yes, and
ma'am. So
high
yes,
temperature,
ma'am.
right?
Yes, ma'am.
In
So
winter you have high humidity, but you don't have high temperature. So you see the fog, right? But you don't see smog formation in winter. You see the smog formation in post monsoon, just before winter, during October, November. Okay, in Delhi the winter starts after December. The coldest month in Delhi is December and January, right? So in winter, though the temperature is low, and though the humidity is high sometimes, but temperature is not as low as or temperature is not as high as in monsoon. Therefore, you can see more secondary formation of particle in monsoon compared to winter. And why the overall particle concentration is low in monsoon? Because there is a rain. So primary particle gets deposited due to rain, right? That is known as weight scavenging. However, at the same time, because of the photochemical reaction and high humidity, right, the secondary formation of particle takes place in monsoon, which is very interesting thing. We always consider monsoon is very clean period. It's a clean period, but maybe it's a toxic. Okay, so this is what I wanted to show you here. Okay, so this is the end of the slide. um, if you want, you can also see this paper which is published. Let me see if I have. Sure. Now, can you see the PPT?
Yes, ma'am.
Okay.
Yes, ma'am.
So until this point, we have learned that the primary emissions of various pollutant is responsible for uh, pollution over various part of um, world, but at the same time secondary formation is also equally important. This is what you can say, you because uh, I have not shown you the amount of primary emission and secondary emission on the same scale, so I cannot make a statement that um, which one is greater and which one is lower. So I'm just saying that this both kind of pollution is equally important. Okay, now air pollution, we have learned that pollutants are emitted from biogenic and anthropogenic sources, and they go through various chemical reactions if they are active. Some of the pollutant they don't even react. For example, CO2 there is no reaction with CO2, but it's a very long lived greenhouse gas. It remain in the atmosphere for long time, while there are short lived gases and which is NOx, sulfur dioxide, etc., which actually they go through various chemical reaction to form other compounds. So now what is the effect of this pollution on various you can say creature, including human and plants and other ecological creature. So we will focus on plant and human and even the monument, the structure or building. So ozone is harmful for crop that this statement I mentioned last time also. Why? Because ozone enters the leaves through stomata during normal gas exchange when the leaves take CO2 from the atmosphere. The ozone also enters as a strong oxidant because this is an oxidant, and I just forgot to mention you this the PAN, which is peroxyacetyl nitrate formation. Actually, one of the uh, catalysts in this reaction, or one, not one of the, there are many. So one of the catalysts in this reaction is O3. In the presence of O3, this reaction takes place and it provides the oxygen to for oxidation of various volatile organic compounds. Other than ozone, OH radical and NO3 are also responsible for oxidation of volatile organic compound and processing of pan formation in the atmosphere. Now, ozone, which is a strong oxidant, cause several type of symptom, including chlorosis and necrosis. And what is chlorosis and necrosis? Here it is shown on the left hand side. The yellowish, you can say, visual appearance on the leaf are one of the disease which is, I think it's a chlorosis. I did not give the name. And this patchy, you can say there is a brown kind of dots on the leaves, that is necrosis. So, but I will write the name. I don't know how come the name of the disease is deleted from here, but I will write it here. Then ozone, we know that depletion of ozone in the stratosphere is causing skin cancer that we have discussed. The other other effect of this oxidation reaction in the atmosphere is corrosion of the metals. So what happens if iron is present in the atmosphere in any form, then the oxidation of iron takes place, or iron takes place in the atmosphere. Similar reaction happens when the iron or any steel which doesn't have nickel coating or anything, when it is exposed to the atmosphere, the iron reacts or get oxidized and form Fe2O3 or other compounds, and that is what the corrosion is. So that happens in the atmosphere because of the presence of some salt which catalyzes this reaction. Okay, so here on the bottom 3 points are written: when metallic surface become contaminated with hygroscopic salts. So hygroscopic salts include NaCl, sodium chloride, MgCl2, and even um, I think calcium compound CaCl2, etc. These are hygroscopic because they can absorb the water and they change their state. So in the presence of these compounds or these salts on metallic surface at even very low RH, 34% or RH, the corrosion of the steel takes place. Sodium chloride on the same surface requires 77% RH to create the same effect. So MgCl2 is very highly hygroscopic compared to NaCl. So even at 34% RH, it can corrode the steel.
Ma'am, what is RH?
RH relative humidity. Okay. So SO2 and SO3 reacts with calcium carbonate and calcium sulfate and gypsum. So we know that this monument are actually made of bricks, and the joint contains some kind of gypsum, or you can say lime, right? They are joined by the lime in old monuments. So if SO2 or SO3 is present in the atmosphere, they react with lime or calcium and form calcium sulfate or gypsum, etc. And this CaCO3 actually get depleted from the joint, and therefore there is a problem, and monument will, you can say, there are images. I will show, I don't have the images. I don't know. So so you can see the old images. Let me find out if I have those images. Maybe I'm just looking on internet because I downloaded those images, but I don't know where did I put them. So let's see. Composition of monuments into air pollution. I will just show you the image because that will explain more than what the words are. Eh, yeah, this is something. Can you see this image? Mm. Can you see this image?
Yes, ma'am.
Yeah. So this is one of the example of what happened. Yeah, this is one of the example of deterioration of monuments due to acid rain means H2SO4 formation in the cloud, HNO3 formation in the cloud, and deposition on monument. So this these are also oxidation reactions. Okay, when H2SO4 is present and it will react with calcium carbonate, it will form calcium sulfate, and there is a like loss of calcium carbonate from the monument. So indirect chemical attack, when pollutant are absorbed and reacts with the component of absorbent. Absorbent here Example, leather becomes brittle after it absorbs SO2. So when leather shoes are outside and if like it's a real leather and it absorbs SO2, it becomes brittle, which reacts to form sulfuric acid because of the presence of minute quantities of iron. Okay, the iron acts as a catalyst for the formation of it. So iron is actually one of the metal which is, if it presents in the atmosphere, even it catalyzes the fog formation. So we had a paper in 2000, I think published in 2016. I don't remember exactly, but it was based on the data we gathered in Delhi when I joined IIT Delhi, and we have seen that uh, that sampling was done in 2009 2010, and during the winter period of that year we have seen high level of sulfur dioxide, in sulfur sulfate and nitrate ions and iron at the same time. So we closely did the data analysis during foggy days and non-foggy days, and we found out that there is a whenever the iron and other catalysts, basically iron is present, the fog formation enhances. Means it's a like due to aqueous phase reaction of sulfur dioxide with H2O and formation of H2SO4, and then ammonium, in the presence of ammonia formation of ammonium sulfate took place, and that ammonium sulfate as a particle remained in the atmosphere for long time. It again actually absorb the water. It provides the surface for water condensation and more dissolution of SO2. So it's a chain kind of, or you can say reaction, right? First SO2 dissolved in water form H2SO4, form NH4 twice SO4 ammonium sulfate, and then this ammonium sulfate particle provides surface to the water to get condensed, and then once water is available again SO2 in the atmosphere get dissolved in water and so on. So that is why the fog was very dense in those period. So and in the same period the iron was high. So iron actually acts as a catalyst in this aqueous phase reaction. Okay, then carbon monoxide. What is the time? Okay, we have 5 minutes. Carbon monoxide. Carbon monoxide comes from incomplete combustion of any carbonaceous fuel, including wood, coal, etc., diesel, etc. And natural formation of CO takes place through anaerobic decomposition of soil by microorganisms that produce 9 into 10 to 15 moles of CH4. That CH4 reacts with OH radical and forms CH3 plus H2O. CH3 reacts with O2 in the presence of light and forms CO. So this is the natural pathway for CO formation. However, the emission from anthropogenic sources are much more higher than natural formation. Anthropogenic sources reaction with hydroxyl radical to form CO2. Zinc, this is the zinc. CO can form CO2 in the presence of hydroxyl radical. Removal by soil microorganisms, that is the zinc. Anthropogenic sources, you know that vehicle fuel burning, I already mentioned that. Health effect of CO. CO is lethal to human within few minutes at concentration exceeding 5000 ppm. If the concentration is 5000 or over, then it's lethal. Yeah, the person can die when he is exposed to such high concentration. CO reacts with hemoglobin in the blood to form carboxyhemoglobin, COHB. Therefore, it actually removes the oxygen. So it has more affinity with hemoglobin than oxygen. and it's actually dissociate the oxygen from the blood, and because of the lack of oxygen in blood the person can die. Formation of COHB effectively deprive the body of oxygen. Then 5 to 10% of CO visual perception will disturb because of the 5 to 10% CO. Manual dexterity, the ability to learn, all this kind of problem may happen due to inhalation of CO. So a concentration of 50 ppm of CO for 8 hours will result in COHB level of. So if anybody who is working near roadside for 8 hours continuously and inhaling the CO, high concentration of CO, in general the concentration of CO is not, means we don't see 50 ppm and above, but there might be, like if there is a traffic jam and the diesel vehicles are more on road, then you may find the high concentration peak in CO. So that that may cause the COHB level increase by 7.5%. Okay. Average concentration of CO inhaled in cigarette smoke is 200 to 500, 400 ppm. So cigarette smoking is more dangerous than smoke, like inhaling the atmospheric air. But this is like you cannot make this absolute, you can say, statement. It depends upon even let's say for example in industrial area where coal combustion is um, uh, you can say very widespread, then maybe it is more dangerous than cigarette smoking. But this is just, you need to remember that cigarette smoking is not good. It's not at all good for health. So this is the global CO emission. We will talk about this in next class. I think we don't have enough time to explain this. Next class we will talk about all these things, and then what is NO2, NO concentration over different parts of the world, and all those things we will learn in this in next class. Okay, thank you. So is there any question?
Excuse me, ma'am.
Yes, ma'am. Ma'am, like what are your opinions on nuclear energy?
Nuclear energy, actually it's a good thing because it's more efficient than your coal and less polluted, less pollution. But I don't know. I never tried to find out its cost effectiveness and its disadvantage, because we all know that once if there is any kind of explosion in nuclear energy, then it will be disaster for whole continent, or even maybe other part of the world also. So in that means I have not tried to analyze the nuclear energy in with different dimension. I know it's efficient. I know that it's less pollution, polluting, you can say, but I don't know its cost effectiveness. I don't know um, once like disaster will happen, then how much uh, disastrous this particular energy is. That I think that is already there in the examples are there from nuclear explosion. That tsunami happened, and in Japan, one of the nuclear power plant got affected, and there was something like that. But I have not explored it. Yeah.
Ma'am, I was not added in the teams for this course. Like, there's still some people left.
I don't know. See, this is the I am adding all of you, but it's not my job to add, because I don't know if institute has added you in the other group.
Ma'am, I have registered for this slot, and I have been accepted on the e-acads, but like we are added on the Moodle pad, okay, but
I will tell you the actual what happens. They when they float the course, they float only one slot, or maybe there are two slots appear, but everybody get registered in one slot only. So in the beginning of this semester, I had 864 member in MS Team and more than 500 in Moodle and ERP. Then we told institute that we want two classes. There are two coordinators. So they segregated and they made two classes after a week. So and they told us they will take care of it. We don't have to bother about adding or removing the student from any of the class. Okay. So that is why I am
I
hesitant
was,
in
I
doing.
was, I am added on the Moodle platform, but like not on the Teams. So the classes attending is a little tedious for now.
Who is this? Who has on their video? Just switch off your video. Switch off your video. Okay. Yeah. So can you email to? I don't know whom will you email. We generally email to Abish and Gaurav. They are taking care of this class division. Uh, maybe maybe UG section, somebody from UG section, just email them and copy to me. So if they say I can add you in the class, I will add you. I added like three student last time, but I don't know what is the strength of my class now. It should
Ma'am,
be more than 250.
yeah, exactly. That's what I'm saying. Like I have been added in the course on the eAcads platform and on Moodle as well. Only the Teams platform is missing.
Okay, let me just see. So already I have 252.
Okay, ma'am, that would
Okay,
including the guests, right? Like many of us are joining as guests in this meeting. Like me and a friend of mine are both not
what
added in
is
the
the
team as
roll number?
2019 E3
EE3.
uh, capitals. Uh,
2019 EE.
you will have to capitalize the E's, capital
Ma'am, I
E's.
guess you have to add the Kerberos ID, not entry number.
Okay.
Okay. Kerberos ID. I tell the Kerberos ID. Maybe E3 0567.
30567.
Yes, ma'am.
I don't get
Uh,
any.
maybe we have to add the Kerberos ID, not the entry number. Uh,
Okay, okay, tell me that.
E3
E
E3
uh,
19.
19
Yes, ma'am. 0567.
0567.
Yes, ma'am.
What the?
Yes.
Ma'am,
Ma'am,
can you please add
ma'am,
me as
one more. Ma'am, CS.
BB?
Who is
Ma'am,
this?
BB. I'm Dev.
Okay, tell me your ID.
Ma'am, BB.
B क्या क्या है?
B for Bombay. BB
Okay,
119
119
00
00
19.
Ma'am, can we
Yes,
leave?
ma'am.
Ma'am, one
Please
more.
add me as well.
one
Ma'am,
E
one.
E
एक एक करके बोलो.
ma'am, CS.
E
Yes,
1190
1190
673.
673.
Yeah.
Aman Gupta.
Yes, ma'am.
Ma'am, can we
ma'am
leave?
EE3
Yes, yes, yes. You can leave. हाँ.
EE3
EE
19
319.
3
एक मिनट.
0877. EE3
19 877.
yes ma'am.
But see, I don't see EE 3193
नहीं नहीं मैम EE3 190877.
087. Okay. What is
MCH.
Ma'am,
MCH.
एक मिनट. What is your name? I can't change.
Chenika.
Chenika. Okay.
Yes, ma'am. Thank you, ma'am.
Okay. Who
Ma'am,
is
one,
that?
ma'am,
Huh?
EE3
E3
0 1 190575
1905
75.
JB.
Yes, ma'am.
तो
MCH11
Yes,
अरे
ma'am.
कितने CH11
Ma'am,
90097
900
97.
97 कार्तिक
Yes, ma'am.
ma'am, BB double one.
I'm CH119. CH119.
मैं अभी ये पता लगाऊंगी आप लोग ये सब
119.
CH
119.
119
0085.
0085
Yes, ma'am. Sriram Harsha.
Ma'am, BB double one.
Thank you, ma'am.
Ma'am, BB double one.
11 एक मिनट
900.
हाँ
9001.
9001
Ma'am, BB double one.
अच्छा BB 119011 हाँ
90015.
90015
Ma'am, ME2
ME
Two.
E2
19
19 19
0943
0
0943.
943
Yes, ma'am.
मैम BB5
कितने आ गए BB5
18 0051
0051
EE3 19
3
190588
5
88. Yes. Thank you.
Ma'am, EE3
E3
19
19
0598
0598
Satvik. Yes, ma'am. Thank you, ma'am.
okay okay bye
Thank you, ma'am.
Thank you,
Thank
ma'am.
you.